Okay, so let's start with the part one, with the first part, and that's refreshing of what sampling is. So you have probably all been to some classes when you have heard about samples and populations, and the fact that your sample is a small set of examples or instances that allow us to conclude some regularities or some generalizations on the overall population. So here I have just represented this relationship like this. So you see that there are different items in the sample and different populations. So the whole idea of sampling is that this small sample somehow represents the overall population. And so here we see what is usually called random sampling. So you just basically you enumerate all the items in the population, and then you randomly select a smaller part. So in our case, when it comes to language and linguistics, those items are texts. They can be words, they can be other units of language. But for this talk, we will imagine that each dot here is a text in some language. It can be in many different languages. So we actually, what we want to do, we want to sample from all possible texts in all languages that there are. Yeah. So of course, you will see that already right away that if we want to do it, as a random sample, that would be really, really hard, because especially if you have small samples, and any sample of language will end up being a small sample, it will be really hard to get all the variation from the whole population. So you will fall on one part of it, and you are likely to have biases, right? So what's more interesting for us, and which is actually the core of this talk, is what is called stratified sampling. So this is a nice trick to have a good representation of the population in a small sample. So you need to know, but the problem is that you need to know something about your population, right? So you need to be able to divide it in some parts, which are called strata. And then from each stratus, you extract the corresponding number of items for your sample, right? So, and this is what is in general called stratified sampling, and this is what is, I think, most interesting for us when we do both linguistics and NLP. So, so here is, so that's what we would like to do, and it would be great to do. But the problem is that we really need to know what our strata are, and in the continuation of this talk, I will explain what are the issues about this knowledge actually. Now let's just take a small pause and then think about why sampling, right? So of course we know, yeah, we need to do sampling because we want to study a small sample in order to draw conclusions about the population. But here I try to make a few more convincing examples from linguistics. So of course in linguistics, our goal is to study all languages, right? So we want to know how language works, and in order to know how language works, well, we need to draw conclusions about all languages. That's really extremely difficult. And so I will just take one example of one topic that is my favorite topic, and that's language adaptation. And so why it's my favorite topic? Because it actually offers some explanations for something that has been puzzling me since a long time ago. This is actually probably the thing that drove me to do computational linguistics. And this is the fact that, some languages tend to have smaller and simpler words, like English, let's say like that, and other languages tend to have long, big, complex words. So I borrowed the terminology from this paper. You have the link here. And so we can call that, if we borrow this terminology, we can call those languages that have shorter and simpler words, we can call them splitters. And those that have longer and bigger words, we can call them lumpers, right? Because they lump a lot of stuff in a single word. So this work on language adaptation is interesting to me because there seems to be a converging evidence from many different studies. Here I list just a few of them that are relatively old already, showing that splitters tend to be languages like this It means languages that whose speakers are more in interaction with other speakers, so there is more language contact. There is more interaction in the sense, like, for example, this paper says that there are more adult second language learners. So we can say that, you know, those languages are kind of together, more interacting between them, and that somehow seems to be driving languages to have shorter and simpler words. On the other hand, we have lumpers, and those are languages that are used in more isolated communities in different areas. And this work of Nichols, she shows that this holds for languages in Caucasian languages. So it's just one group of languages, but she could find a correlation between the geographical altitude and morphological complexity, right? So that's for me, it's interesting. Now, I think it becomes evident that in order to show such correlations, you need to have really different languages, right? So you need to have short and long words and all kinds of things in your sample, right? But one important thing to note is that even if you have, you know, a relatively big sample and diverse, this does not guarantee you that you will have good generalization. And so here I have one example of a paper from 2007. That's this paper, Hay and Bauer. And so even before this paper, there had been work on the, you know, connection between the phoneme inventory, like how many phonemes there are in the language, and the population size, right? And so this paper found a positive correlation, means that languages that have more speakers have more phonemes, yeah. And so, but other people thought, that's really curious, you know, interesting. And then they went on, like Moran et al., to reanalyze the data by Hay and Bauer. And they actually found much less evidence. So they found very weak correlations and in different directions, right? Sometimes positive, sometimes negative. So that's a bit not so coherent evidence. And all of this is explained, you know, by the fact, so the correlation that Hay and Bauer found was most likely due to the heterogeneous sample, so that so we can say that this correlation was sort of accidental, right? And Moran et al., when they looked inside of subgroups, so like let's say inside of language families, then this is where the correlation didn't hold anymore. Yeah. So those are nice reminders on why and how sampling is important. So how we need to really think of what is our population and how we can represent it, yeah? And even if we cannot perfectly represent it, there will be always a lot of obstacles to representing correctly our population. We can always you know, try to go to something that is more reasonable and that it will actually allow us to have better generalizations. Now, when it comes to NLP, so I think here also things become relatively evident, right? So in NLP, what we want to do, we want to have, you know, some output when we give a text as input. So let's say that we come across a Twitter message, right? And so these are the things that we want to do with NLP. So we want to know, for example, whether this Twitter message is positive or negative. What is the topic of it? What is the language in which it's written, right? And finally, what is the translation in the language that I know? I said finally, but there are actually many other tasks that we do. So those are all called NLP tasks, right? And so we have a text as input, X, and for the same input, we want to have different outputs, Y. And those outputs will be produced by models. Now comes the sampling. So those models will be trained on a sample, always and necessarily, right? Now, the success of our model will be, of course, dependent on how good the model is, but there is really, really strong relation between this. So our model will do well if the message that we see, if the text that we see is not a big surprise to it. So if we had nice representation of the population in our sample, our model will have better chance to do well. So that's the reason in why we need good sampling in NLP. Now here we come to the part where we show how these things are connected in both in linguistics, in NLP. Actually, the problem is that we cannot really build either hypotheses or models without having some assumptions about languages, right? So whenever we work on any language, although in theory we could work in a language independent way, in practice, we always include some assumptions about the language. And one of these assumptions, for example, that's a very simple example, is about tokenization, right? So for a long time, we assumed that words are the tokens on which we do calculations, right? And so here's a small example from a Bible, because we use Bible for our own study. So this is why I have examples. And so, you know, since recently now we understand that actually this is not a good representation for processing language. Subword representation is a little bit better. Now the question is still open, which subword, because as you can see, when you go subword, you can have many different options. But still, models work better at some, we can say, at arbitrary subword levels, you know, and this is still probably a field of research, and we are also trying to find out which ones are better. So the whole point here is that if we didn't, so we introduced subword tokenization because we needed to deal with long and complex words, right? But if we only had languages such as English that have relatively short and simple words, we might never even thought of subword tokenization. And now that we have it, it actually works better even for English, right? It works better for all languages. So that's another example where I think sampling is, so that the importance of sampling becomes relatively evident. Okay, so this is the end of part 1.